Hello everyone. Today I'm going to talk about the mechanism and service scenarios of the Yang storage model of the Agile Open Container, or AOC, from 4 parts. Yang storage model, CRUD of the RDB, two-phase storage, and multi-service isolation. Before learning about the Yang storage model, you expect to have a basic understanding of the Yang syntax. For details, refer to RFC 6020 and RFC 7950. Before starting with the first part, we need to be familiar with some terms. 1. Data store is a module used by the controller to process the Yang storage model. 2. Yang tools is a module for passing Yang files to generate tree-structured memory models. 3. DB is a database module which stores configurations, including CDB and RDB configurations. 4. Candidate database, or CDB, is a database module which caches the configurations to be delivered to devices. 5. Running database, or RDB, is a database module which saves the configurations delivered to or synchronized from devices. 6. Schema context is a tree-structured memory model generated after Yang files are passed. 7. CRUD refers to the create, read, update, and delete operations on the database. Let's start with the first part, Yang storage model, or data store, which complies with RFC 6241 and RFC 8342. These standards define multiple database modes such as CDB, RDB, and startup database. Currently, the NCE controller mainly involves the CDB and RDB. The storage process is classified into 2 types. The first one is that service configurations are directly delivered to devices and saved to the RDB. The other one is that devices are configured and configurations are delivered in two-phase storage mode. In the first phase, configurations are saved to the CDB, while in the second phase, they're delivered to devices and saved to the RDB. Currently, the Yang storage module provides the following functions. Establishes the relationship between Yang models and data storage models and implements the CRUD operations on corresponding storage models. Configures devices and delivers the configurations in two-phase storage mode. For multiple services, performs operations on node configurations of the same NE. This figure shows a hierarchy between Yang models and data. The Yang tools module uses open source software to parse Yang files and generate a tree-structured memory model schema context. The data service processing layer provides a Yang data storage model, converts the schema context into a data storage model, and performs CRUD operations on Yang nodes. The DB is a database module, which stores device configurations. Currently, the data store supports 2 Yang data storage models. One is the JSON table. In this model, Yang node configurations are stored in JSON format. That is, in the corresponding database, a column stores a series of node configurations in JSON format. To prevent too much information from being stored in a database field and support data reading and writing, the stored data is split into tables based on certain rules. As you can see in the figure, tables can be split based on the list or container. The parent table stores the leaf value of the parent list node. The child table stores the node values of the child list, and the parent-child relationship is constructed based on other field information. The corresponding nodes in JSON format are as follows: name of node 1, value of node 1, name of node 2, value of node 2. The other is a two-dimensional table. Unlike the JSON table model, this model uses a database column to store a node value, which can be leaf or leaf list, in the database. Similar to JSON, nodes in the Yang model also need to be split into tables of storage based on specific rules. The figure shows the mapping between the Yang model and two-dimensional table. These two storage models have their own advantages and disadvantages. In JSON table model, the database structure does not need to be modified. Instead, only the JSON value needs to be modified during the upgrade, facilitating the Yang model upgrade. However, the disadvantage of this model is that table fields are too long. The leaf fields in a two-dimensional table are independent of each other. However, if a field type is changed in the upgrade scenario, the column type of the database may need to be changed, which complicates the upgrade. The two-dimensional table model enables flexible query and write operations and delivers high performance. Currently, the two-dimensional table model is recommended for data storage. Next, Let's move on to the second part, CRUD. In the first part, we talked about the abstraction of the Yang model and saving of device configurations or pre-configurations to be delivered in the database. Services need to save and read device configurations through the data store, which needs to provide interfaces for the create, read, update, and delete operations. As shown in the figure, services can create, read, modify, and delete existing configurations in the database to ensure configuration consistency with devices. In the third part, we'll talk about two-phase storage. With this mechanism, devices can be pre-configured, in which the configuration data is saved to the CDB, and then configurations are delivered to devices, meaning that data is saved to the RDB. This ensures that service configurations either all succeed or all fail. As shown in the figure, the pre-configuration may vary between users. Configurations that have been delivered to devices can be rolled back. The CDB saves multi-user service configurations locally without delivering the configurations to devices right away. It also supports transaction-level configuration delivery. To ensure service reliability and security, two-phase storage uses the optimistic lock mechanism to control concurrent service operations. During pre-configuration, the version information of the corresponding configuration is recorded. When the configuration is submitted to the RDB, the version information of the configuration is verified. If the configuration has been modified by other users, you cannot modify the configuration. Instead, you need to make modifications on the latest configuration. Next, let's shift our attention to the last part, service isolation. Currently, the Yang model driver of the controller supports the data source capability. The data source is recorded to allow multiple services to share the same Yang model. Currently, a large number of device models need to be configured. In this case, device models can be extracted to generate service models. Each service has different NE model nodes, which may overlap. Device configurations also vary between services. How can configurations be differentiated in the storage model? This is implemented as follows. The database configuration information records the source of the service configuration. CRUD operations are performed based on services. As you can see in the table, the database records not only the node configuration, but also the corresponding service source. The tree in the figure on the right shows the Yang model nodes. Node A records two sources in the database, service 1 and service 2. Node B records one source, service 1. Other nodes record the corresponding service sources. After querying, it is found that service 1 involves the configuration of 2 nodes and service 2 involves the configuration of 3 nodes. This is how device configurations of different services can be obtained. The prerequisite of this is that only one node can be configured for different services. In this case, the policy for handling service configuration conflicts is involved. When a configuration conflict occurs, policy control is performed based on service security and integrity. I won't go into further details here. That's all for this topic. Thanks for watching.